Hello, welcome back for another tutorial on Oracle Index. So last time we talked about B-tree index and then reverse B-tree index, and then in this scenario we're going to discuss some another kind of problem. So let's say we have this employee table in our database, and then employee table has basically a couple of 100 rows like that, and then if I ask you to find out, tell me what is the job ID, basically who are the salesmen in my company or who are the accountant in my company. Okay, so to do that you need to probably give a query like select star from employee where job id is equal to accounting. Okay, accounting. Okay, so notice here that we never created an index on job id column. In the previous two videos we already created an index on employee id, but since we are asking this kind of questions, we cannot again use any index. We are going to do a full table scan. And now let's say we are going to do a create index on this job ID. And if you create index job ID on a B-tree index, then what's going to happen is that if you see if you do a distinct of your values, maybe you are going to assuming that you are using the sample schema provided by Oracle some installation, that you are going to have accounting, and somebody might have sales, engineering, and so on. Okay, there are a couple of maybe 4 to 5 rows max. Okay, so four to five distinct value for this job ID: accounting, sales, engineering, and development or something. Okay, so now the question is, if you want to store them on a B-tree index, so how do what we could do that? Okay, anything between A to P, you go to the left side, and anything from P to G go to the right side. Okay, so that way we are going to do, and then basically construct our B-tree index, and then finally what we're going to do, we're going to have something like accounting row ID, again another accounting row ID, because in the multiple of accountings are there, right? So what we are doing here, if you store this thing, if you can create an index like that, and not a problem. But if you create an index like that, what you are doing is you are repeating this accounting multiple times with different row IDs. Okay, and also if I ask you another question, what is job ID is in accounting or in sales? Okay, I put some more condition here, right? So basically in that case this B-tree index may not be a good implementation. Okay, and so I hope you understand the problem of implementing this kind of basically a scenario where we have where we have repeating values. Okay, where repeating values, B-tree index may not be a good idea. To Oracle gives you another type of index called bitmap index. Okay, so bitmap index is basically the way to solve this problem. So let's try to analyze what is bitmap index. In a bitmap index, it's a two-dimensional array in one column. Okay, so let's say this is a two-dimensional array. So I'm going to draw like this, a two-dimensional array. In whatever the distinct value of this job ID, like accounting, and then let's say another thing is called sales, say another job ID is called clerk. Okay, so a two-dimensional array. So basically let's have this thing accounting, sales, clerk, and another, say for sake of completing this table, let's say called engineering. And then what we're going to do in this columns, we are going to have the actual number of rows here. So let's say this table, the employee table, whatever I'm doing, has 100 rows. Then 1, 2, 3, 4, up to 100. Is it clear? So this is how I'm going to clear. So now what I'm going to keep here, either a 0 or a 1. Okay, so the value of this cell can be either 0 or 1 depending on if the row ID 1. So basically the employee ID is Steven is basically, let's say this is a clerk. Okay, so if it's a clerk, then this accounting value will be 0, and then clerk value will be 1, other values will be 0. Okay, let's say this employee number 2 is a salesperson, then that value will be 1, other value will become 0. Let's say employee ID 3 is a engineer, so employee is this bit is 1, other bits are 0. So this is the way that we're going to construct a bitmap array. Okay, and by constructing this bitmap array, let's see how the query is going to respond to this kind of thing. So the moment you do, say, select star from EMP, where job ID is equal to accounting, then what it's going to do is going to scan to this row here. Okay, and wherever we have 1, okay, so wherever we have 1 is going to return that row ID. Okay, so if the moment you do accounting, it's going to scan this thing accounting, and then let's say this is 1, this is 1, so basically it's going to return me row ID 4 and 5. Okay, so this is going to be very fast, because it's just going to scan only this one, and then also the operation that is going to do just a binary operation, a bit operation. Now let's say somebody gives you a query, select star from MP, where job ID is accounting or job ID is clerk. So what are the employees? They are satisfying these 2 conditions. This thing can answer your thing right now. So employee ID accounting is this row, clerk is this row. So since this is a OR, so what you do, you take these 2 things and do a logical OR on this thing. So 0, 1 is okay, the value is 1, so therefore you're going to return the row ID 1. 0, 0, no, it's not a accountant, not a clerk, therefore it's not going to return. Then it's again 4 is going to return and 5 is going to be returned. Okay, so look, like by doing this thing, if whenever we have this kind of condition in the query, okay, so this kind of implementation of index is much faster. I tell you, you can create also a B-tree index on this thing, but in this case, B-tree index will not help. But here is another problem. The problem is, whenever we are going to do some update, so update employee, say the job ID is equal to something else. You say from accounting, you put something else. So we're going to put from accounting to say some salesman, okay, for employee ID say 54. So we're going to update that one in the base table, and also we need to maintain the index. That means we need to update this accounting bitmap to 54. That means what is going to happen that time, just to update the employee ID 54, this guy is going to lock the complete accounting data. That means all the employees who are supposed to be accountant, they are, because we do not know at this time, we know this 54, but we want to update this bitmap, right? So in order to update this bitmap, we have to lock the complete entire detail of the accountant, the employee IDs whose job ID is accounting. Okay, so that is a big problem whenever you have a OLTP system where we are trying to do some update, delete, and those kind of things. If you are doing, then definitely bitmap index is probably not the right way to implement your thing. But whereas bitmap index has a huge use case in the data warehousing kind of application, where we are doing some reporting, where we are doing some reporting on some read-only data. So that is a way that if you do a bitmap index, in that case, it's going to it's going to improve your query, like humongously. I have seen in my real life that something that's going to take 10 minutes can be done in a fraction of a second by using bitmap index. But you should understand the bitmap index, bottleneck. And also another thing, that if you want to know, you cannot operate in inequality operators. Like, for example, if you want to select star from MP where job ID is greater than cells or not equal to cells, so greater than cells, in those kind of things you cannot get by using bitmap, because bitmap is very very binary. It's either the thing is there or not. It doesn't do any inequality operations.